Welcome back, students. Good morning to all. In class 8, we are discussing about physical and chemical changes, our unit 2. From this chapter, today we are going to discuss about the energy change in physical or chemical changes. All of you, please take out your book and stay on video, watch the video carefully. Okay, students, here is our topic: physical and chemical changes involve energy change. There is a change in energy when a physical or chemical change occurs. Energy usually in the form of heat. Energy change usually in the form of heat. It can be taken in or given out. Heat can be taken in or heat can be absorbed, or given out means evolved. Heat can be evolved by a substance undergoing a change, either physical or chemical change. When a substance undergoing a physical or chemical change, heat can be evolved or heat can be absorbed. So there is two definitions of these two different conditions: heat evolved and heat absorbed. First one is a change during which heat is given out is called exothermic change. A change during which heat is given out or evolved, that is called exothermic change. Another one, a change during which heat taken in or absorbed is called an endothermic change. An endothermic change. Okay, students, heat is absorbed, that is called endothermic change. When heat is evolved, that is called exothermic change. There are many changes. There are many changes which are neither exothermic nor endothermic. The formation of a heterogeneous mixture is a common example of this type of change. When sand is mixed with salt or water, no heat is given out or taken in. Now, we are going to discuss energy change in a physical change separately. First one, changes in state. Many times we have discussed about the changes of state, especially in case of water. Ice to water, water to vapor, or vapor to water, then water to ice. We have discussed many times. Energy changes take place during a change in state. Change in state, if a substance changes its state from one to another, energy change takes place. A solid absorbs heat in order to melt. To melt, a solid absorbs heat. A liquid absorbs heat in order to change into vapor. Solid absorbs heat to melt. Liquid absorbs heat to change as vapor. Thus, these are endothermic change. It absorbs heat. Solid and liquids absorb heat to change. So, these are good examples of endothermic changes. On being cooled, gases and vapors condense and liquid freeze. Heat is given out in this process. So, these are exothermic changes because heat is given out here. Heat is given out here in this process. So, these are exothermic changes. If heat is absorbed, those are endothermic changes. Now, we are going to do one activity here. Take a little water in a steel or glass bowl. Pour boiling water into a mug. Clear? Take a water in a steel or glass bowl and pour boiling water into a mug. Hold the bowl over the mug. Hold the bowl over the mug. Steam coming out from the mug will condense as it comes in contact with the bowl. After some time, you will find that the water in the bowl has become warmer than before. After some time, you will find that the water in the bowl has become warmer than before. Okay? On being boiled, water changes into vapor. The water vapor condenses, transferring heat to the cold water in the bowl. So, the water in the bowl becomes warm. Clear? The water vapor condenses, transferring heat to the cold water in the bowl. That's why the water in the bowl becomes warm. Now, here is one example given. Steam evolves heat while condensing. See, this is the activity which we have done. Okay. Steam evolves while condensing. Okay. Maybe you have done this activity. You can do very easy activity. Now, why an energy change in a change of state? This happens because the kinetic energy possessed by the molecules of a substance is different in different states. Okay, about the kinetic theory of matter we have discussed. Kinetic energy is different in different states of matter, solid, liquid and gases, we know that. Okay, it is the lowest in the solid state. Kinetic energy is lowest in the solid state, higher in the liquid state and highest in the gaseous state, because the molecules are arranged tightly in the solid, a little loosely in the liquid and far away in the gases. So, energy will be absorbed by a solid to melt and a liquid to boil or vaporize. And heat will be evolved by vapors to condense and a liquid to freeze. Heat will be evolved by vapors to condense and liquid to freeze. Okay. Now, dissolution. Many substances evolve heat, whereas some others absorb heat. Many substances evolve heat. Clear? And some substances absorb heat while dissolving in a solvent. You can test this by doing the activity. Hold a glass in your hand. In your hand, hold a glass. Pour some water into the glass and stir it after adding a couple of spoons of glucose. So, take a glass water and add some glucose in it, then stir it. What will happen to it? The glass will become slightly colder. We can feel the cool after dissolving glucose in it. Thus, the dissolution of glucose in water is an endothermic change. You can get back the glucose by evaporating the water. By evaporating the water, you can get back the glucose, okay? Because glucose absorbs heat from our hand. It absorbs heat from our hand, that's why we are getting cool. Okay? Now, when you put some glucose on your tongue feels cool. Why? While dissolving in the moisture of the tank, glucose absorbs heat from tank. So, your tongue feels the cooling effect. Glucose absorbs heat from it. That's why we are feeling cool. On the other hand, other example, if you add some bathroom acid to water, heat is evolved, concentrated hydrochloric acid. Okay, heat is evolved. Now, why an energy change in dissolution? During dissolution, the solute particles break up from the main bulk and hide themselves in the intermolecular space of the solvent. During the dissolution, what will happen? This point we have already discussed. The solute particles break up from the main bulk and hide themselves in the intermolecular space of the solvent. This affects the motion and so the kinetic energy of the molecules. The kinetic energy, that Ke of the particles, depends on the temperature. And so, a change in the kinetic energy will result in the absorption or evolution of heat. Change in kinetic energy will result in the absorption or evolution of heat. Okay. Now we are going to discuss energy change in a chemical change. Okay. All chemical changes involve a change in energy. All chemical changes involve a change in energy. First one, burning. You know that both heat and light are emitted when anything burns. Here it shows burning a matchstick. In this case, both heat and light emits. Both heat and light emits. Another one, photosynthesis. In photosynthesis, chlorophyll, the green pigment of leaves, that is called a chlorophyll. The green pigment of leaves is called a chlorophyll, absorbs sunlight and helps the plant produce glucose and oxygen from water and carbon dioxide. Clear? Now, slaking of lime. You have learned that the slaking of lime is highly exothermic reaction. Last year we have learned that slaking of lime is a highly exothermic reaction. So, much heat is evolved. In this case, much heat is released or evolved when water is added to quicklime. Clear? That is why the water boils during the reaction. Heat evolved. So, slaking of lime is an exothermic reaction. Slaking of lime is an exothermic reaction. Here the chemical equation is given: quicklime plus water gives a slaked lime plus heat. Okay, quicklime plus water gives slaked lime plus heat. Please underline and study. Now here is a point why an energy change in a chemical change. A chemical change involves what's happening? There it happens a rearrangement of atoms. The reactant molecules break up and the product molecules are formed. The reactant molecules breaks up and product molecules are formed there. These processes are not only opposite in nature but involve different amounts of energy too. So in the overall process, there is either a surplus or a defect of energy. Either surplus energy or a defect of energy. If there is a surplus energy will be given out, and if there is a defect energy will be taken in. If there is a surplus energy will be given out, then there is a defect energy will be taken in. So there is a energy change in a chemical change. So there is a change in energy in chemical change. Okay, students. Now we are going to discuss an important point. Energy requirement for the completion of change. Energy requirement for the completion of a change. This is our today's last topic. Clear? It will be discussed tomorrow. Till then, wait for the video, wait for the class. Now, goodbye and have a nice day.